the normal distribution as a model. A gas engineer claims that the time t in minutes it takes him to repair a boiler is normally distributed with a mean repair time of 60 minutes and a standard deviation of 30 or variance of 30 squared. Okay, so if we sketch the actual normal distribution for this continuous random variable t, we get a sketch like this where the mean 60 goes in the center, and then you can add one standard deviation to add 30, add two standard deviations to add 30 again and again, and subtract 30 going the other way, so you end up with these values. Now these values should be sensible within the context of this problem, and the context states that t is a time, the time taken to repair something. So our normal distribution here is predicting negative values here, and these negative values are a complete nonsense. So this model does not represent the time taken for this engineer to repair a boiler, because it's predicting negative values. So if you start with the mean value, all of the values up to 3 standard deviations from the mean in either direction, so all of these should be sensible. Okay, the mean plus 3 standard deviations and the mean minus 3 standard deviations. These should be sensible in that range. Outside that range, so if you went as far as 4 standard deviations on each side, we're not going to look at those, but it should make sense within 3 standard deviations, because this represents 99.7% of the total distribution. Okay, second example, same context, different normal distribution. The standard deviation and variance this time is different. So again, if we work out the actual values of t that go along here, so the mean is 60, that goes in the center, then you keep on adding 5 this way and you subtract 5 from here going towards the left, so you end up with these values, and this time the values are sensible. Yeah, there's no negative values there, and the last 10 jobs that this engineer attended had their times recorded, so these are the times taken to repair these boilers. So if we work out the mean, variance and standard deviation for this data, we can compare those values with what the normal distribution here is stating. So I'm going to enter this data into the calculator to work out the sample mean and standard deviation the quick way. So reset the calculator first, shift 9 3 equals, press the AC key, and then mode, statistics, one variable, option 1 there, enter the data, okay, so the data is in there now, 120 there and 12, the last two values. Clear the display and shift, statistics there, option 1 there, variables, it's 5 on this calculator, it may be 4 on your one. I've picked the wrong one. Okay, so the mean is option 2 there, press equals, so 60.5 for the mean. And as you can see, the means are similar, so that's good. And now the standard deviation, option 4, that's the sample standard deviation, 37.4. can see that the standard deviation for the population is 5 from the normal distribution, and from our data here the standard deviation is 37.4. They're not similar, so they don't agree. And only if the means and the standard deviations are similar would we say that this normal distribution is a good model for this data here. It's a good fit for that data, but clearly in this case it's not. Example 3. We have a company here that manufactures temperature sensors, and the temperature measured by the sensors is normally distributed with a mean of 0 and a variance of 0.2. And of these 10 sensors, if any of these temperatures are outside of this range, they will be discarded as faulty. Okay, so first of all, we've got the mean, which is 0. There's the mean, 0, plus or minus 1 standard deviation. That's not the standard deviation, that's the variance. So you have to square root that to get the standard deviation. Okay, the square root of 0.2 is 0.447. Okay, so we've got 0 plus or minus 0.447, or in other words, any temperature from minus 0.447 to plus 0.447, so any temperature that's reported in that range there shows that the sensor is working, it's accurate, and any temperature reported outside this range would be an error of some sort. The sensor's got a problem, that sensor would be discarded. Okay, so let's go through the list. 0.28 is within that range, so this range is the acceptable range. So this one's fine, minus 0.43 is fine. This is outside the range, so sensor number 4 will be discarded. This one's fine, this one again is outside the range, so 6 is also discarded. That one's okay, that one's okay. 0.9, that's too high, that's discarded, and that one's okay.